Hi guys. So what we discussed in the last lecture? Okay. Hmm. Okay. You can remove that VBox guest edition. Hmm. Then what's the issue? I'll check that. Okay, after the class. Okay. So let's try to understand about a very important concept. We called it as a Oracle multi-tenant architecture. Okay. So everyone know about it. This multi-tenant architecture. Okay. Can you see my screen? You can see my screen, right? Okay. So let's try to talk about that. You can remove that VBox case study. Okay, some issues. So now in the Oracle multi-tenant architecture, let's try to understand that. Okay, let's try to understand this Oracle multi-tenant architecture, which has been started from Oracle 12c only. So what is this multi-tenant architecture, and let's try to understand that. So if you consider the previous architecture, the core architecture of your Oracle database, like in that what we have done, like we had a server, okay, and on that server we had multiple database were there. Let's say this is my database 1 and this is my database 2. Now every database will have their corresponding SP file was there, parameter file was there. So this database also have their corresponding SP file, and in that SP file you are going to specify the amount of memory that you want to allocate to your Oracle database. Let's say you allocate some memory here 50 GB, and here you allocate some 20 GB only, and both the databases are connected to their respective applications, right? This got connected here and this got connected to their respective applications. Now what happened, like this application is demanding more memory, that is the reason we allocate 50 GB here. This application demanding, this database is demanding lower memory, that is the reason we allocate 20 GB here. But there will be certain situations where this 20 GB is not sufficient, so it is looking for, now let's assume that 30 GB, and here you allocate 50 GB, but now he is taking only 40 GB of memory. Now the problem is, like when you have a memory which is allocated to your particular database system, even though he is looking for less memory and he is having more memory, actually he is having less memory but he is expecting more memory, but the problem is they are not able to share the memory of each other, right? Because database 1, that is the maximum, 50 GB is the maximum, less than that he can use. Database 2, the maximum is 20 GB, more than that he cannot use. But the problem is, like they are not able to share the memory resources among each other. So what you can say that, like when you find out the resource utilization, you can see here that the resource utilization is not that up to the mark. Maybe you are using just 50% of your resources. That is the first problem. Second problem is like, let's say in future you want to apply some patching activity. Okay. When you want to apply the patch, you need to apply the patch separately on the database one, and then you need to apply the patch on the database two separately. So say, even though it is the same process, but you need to apply that process 2 times, right? You need to apply that process 2 times. So both the things you need to do 2 times, right? Both the things you need to run that 2 times. So that is also one big problem, correct? That is also one big problem. So you need to take that downtime 2 times, and then you need to perform the same activity 2 times, correct? If you want to upgrade your database, let's say you want to upgrade your database, you need to upgrade this database separately. Database 1 you need to upgrade separately. And once the upgradation get completed, again you need to upgrade this database separately. Database 2 also you need to upgrade separately. Let's say you want to upgrade from 11G to 19C, and here also you want to upgrade from 11G to 19C. So 2 times you need to do the upgradation process. Now all these problems, like all these problems we were facing when we were talking about the non-multi-tenant architecture or non-CDB database. One more problem is like, if you talk about the background processes, like it will have his own background process, pmon, yesmon, dbwriter, logwriter. This database will have his own pmon, yesmon, dbwriter, logwriter, database buffer, cache, log, read log buffers, everything. Whatever core components we know, everything will be double, right? So to avoid this problem, they thought like, okay, let's have something like a container and pluggable database architecture, and they are calling it as a multi-tenant architecture. What they are calling it as multi-tenant architecture. So in the multi-tenant architecture, what they have done, they have created one server. Obviously, we had a server. On that server, we will have a container database, and under that container database, we will have your multiple pluggable database will be there. Under that container database, we will have multiple pluggable database will be there. Now this pluggable database will be looks like this. This pluggable database will be like, let's say this is my container, and under that container I will have a pluggable database like PDB1. I will have a pluggable database like PDB2. You are going to connect your application to this pluggable database only. Let's say this is getting connected to the application 1, and this is getting connected to the application 2. And when you get the request to create a user, you are going to create a user under pluggable database only. Here you are going to create a user under pluggable database. And this pluggable database user will create their respective objects like table and all will be created under pluggable database. So what was the problem that we were facing initially? The problem was resource utilization. Now here, whatever amount of memory that you are going to allocate, that will be allocated on container level. Let's say you allocate some memory like 100 GB on container level. Now if PDB1 is saying that I want 70 GB at this point, so PDB1 will get 70 GB, PDB2 will use 30 GB. Later on he is saying that I want 30 GB, he wants 70 GB, that's okay. So basically whatever amount of memory you have given, that is on container level, and that has been shared among the different pluggable database. In this case, what will happen? Whatever amount of memory which is available on container level, that will be shared, and that is like, your resource utilization is very good because your memory is dynamic now. Your memory is dynamic. Another good thing is, if you talk about the patching activity, when you want to apply the patch on your container level, let's say you are applying a patch on your container level, that will get applied to the pluggable database level also. So within a single shot, you are going to patch both of your databases. Third thing is, if you want to upgrade your database, let's say you are using 12C container, so their pluggable database will be of version 12C only. And if you are upgrading this from 12C to 19C, automatically their pluggable database also get upgraded to the 19c within a single shot. All the pluggable database get upgraded to the 19c. And if you ask me about the background process, all the background process will be there on container level only. Like if you fire a command like ps-ef grep pmon, you can only see the instance of your container level, that is a prime database. You cannot see anything related to the pluggable database. So all the your db writer, log writer, database buffer cache, everything, whatever you have seen the component, everything will be on container and all are shared between the pluggable database. So no repetitive background processes. And one more important thing is, which I want to add related to the licensing cost. See, when you are using the Oracle database, it's not free of cost, right? You need to pay the license. You need to purchase the license and then only you can use that. Now, these licenses are something which I can tell you, compared to the non-CDB database, this pluggable database license are pretty much easy, pretty much cheaper compared to the, because when you say that I want two databases here, this db1 and db2, you need to take two license. Here, along with the container database, there are two pluggable databases are free of cost. First of all, it is free of cost. And again, when you want to purchase one more license of PDB, that is comparatively it is very cheaper compared to the non-CDB database. It is cheaper also. And basically, you know, management play a very, very important role. If I want to compare this with the real-time example, or if I say a non-technical example, let's say there is a Google container. Under that Google container, you created multiple pluggable database. Let's say PDB1, you created PDB2, then you created PDB3, then you created PDB4. Let's say you created multiple pluggable database. All these pluggable database you can attach to one application. Let's say you attach it to the YouTube, you attach to the search engine, which is a Google search engine, you attach to the Google Drive, and this one you attach to the, let's say, Google Form. These are the different applications are there under this container database. So actually in container multi-tenant architecture, container database is to store only metadata information, metadata. And all your actual data gets stored under your pluggable database only. So your users, their respective tables, anything, whatever you do, everything will be there on your pluggable database level only. And that's the multi-tenant architecture. So your actual data gets stored under your pluggable database. Understood? Multiple pluggable database, correct. Correct. But all the pluggable database, whatever it is there in that will get patched automatically. See, you consider that instead of creating these two databases, okay, can I add them into this pluggable database only as a PDB1 and PDB2? You can. What I will do, I'll replace this with as a PDB1 and PDB2, these two databases. And if you want to add one more database, it's very easy to create a new pluggable database also. Very easy. And then it will be the part of that, this container only. You got my point? Yes, like that. Tell me some of them. Correct. No, that's not possible. Correct. You need to go to the container level and then you need to take that. That's the problem with the, even I have observed that in the multi-tenant architecture, basically when you want to restore it, you need to restore with CDB and PDB both the things, because CDB have the metadata about that. So usually when you want to take the backup of a pluggable database, you take the backup of CDB plus PDB, like that, because a root that enter that CDB, there is a root container is there. Okay, CDB $root we called it as. That does not store anything, but actually it is storing the metadata information about your pluggable database. Okay, so yes, right, correct. That does not store much data CDB level. Okay, because CDB we are not creating any user, any tables, nothing will be there. Okay, and as per my knowledge, what like, maybe I'm not again correct also, we cannot restore only one PDB. Restore means along with the CDB only you need to restore that. Hmm. PDB $seed. Because that is a read-only database. Correct. Correct. So let me show you all these things, whatever we discuss practically. So I'm joining Fib. Okay, let me start here both the machines. See, starting from Oracle 12c, they have started the Oracle Multitenant Architecture. Okay. Now the thing is, in Oracle 12c and 19c, it was like whether you want to use, you can use. If you don't want to use, you don't use. But starting from Oracle 21c, compulsory you need to use. So there is no scope whether you want to use or you don't want to use. See, there is advantages also. The one which I told you, there is a disadvantage. I'll tell you what is the disadvantage one more time. The problem is, like, let's say you stop your container database. Okay. Then what will happen? All of your pluggable database will be down. Correct. That's also a big problem now, right? So by any chance someone mistakenly stop the container database, then it's a big problem, right? But what is the use of this multi-tenant architecture is it is behave like a plug and play. Okay, plug and play means, let's say I have two containers are there. Okay, let's take an example here. I have two containers are there here like this. Under that, this is my CDB1, this is my CDB2. Here I have my two pluggable databases are there, and here is my only one pluggable database. Assume that you don't want to run this, you don't want to run this PDB from this container because of certain activity. Maybe you are trying to upgrade this, this complete setup, but you don't want to upgrade this. Okay, so what you can do, you can easily unplug it and you can plug it here. It is like a pen drive only. If you want to see a movie from here, you can see that. If you don't want to see, unplug it from here and plug it here. That is also possible. Two different instances, correct. This is my prime database, you consider that. This is my test DB. Same server. Assume that this is having one Oracle home, like let's assume that data app Oracle product 19C DB home. Okay. And this will have 12C DB home. But both are container database because 19C and 12C both are container. So it is possible. (21C). 23C, where is it? Where it got released? Let me show you. 21C multi-tenant compulsory. Common mandatory profile. Multi-tenant container database is the only supported architecture in Oracle 21C. Right. Starting with the Oracle 20, non-CDP architecture is dis-supported. See, right? So be ready for that. So if I go here and if I try to log in with Oracle, so let me connect. Just give me a minute. Okay, so let me connect to the SQL plus. So I'll fire a command like SQL plus /s sysdb. I just fired this command. Now when you fire the command like SQL plus /s sysdb, if you want to know whether you got connected to the container level or pluggable database level, you can fire a command like show connection underscore name. So here I can see that I got connected to the container level. CDB $root is the standard root container. If I want to know what are pluggable database are there, so I can simply fire a command like show PDBs, and I can see these are the two pluggable databases are there. PDB $seed and PDB prime is the two pluggable database that I can see over here. PDB $seed and PDB prime. That yes, PDB $seed will be created automatically as soon as you are doing the multi-tenant architecture installation. Okay. This database is mainly useful to create a new pluggable database. Now you can see that this pluggable database is in read-only mode, correct? It means you cannot make any changes into this pluggable database. If you want to create new pluggable database, then you can create a new pluggable database either from PDB $seed or you can create from PDB prime also. Customize PDB, or you can say all the data will be cloned to that new pluggable database from this PDBs. Okay. So only PDB means that is possible, na? You create one more 19C here, okay, which is having multi-tenant architecture, and you can have your all the pluggable database will be in sync with the data guard. That is possible. So what I will do, I want to now currently you can see here this pluggable database is in mounted stage, right? What is this? Mount. when you say that currently this database is in mount, it means this pluggable database is not running. Now if I want to start this pluggable database, I can simply fire a command like alter session set container equals to PDB prime. So where I'm right now connected, show connections underscore name, I got connected to the pluggable database. If I want to start my pluggable database, I'll simply use a command like startup and it will start my pluggable database. So remember one thing, that most of the commands which you run on the container level, same command you can run it on pluggable database level. Only the thing is the impact will be based upon where are you right now connected. So let's say you want to create a user, you can create a user in container also and pluggable also. Both are having same command. But if you fire the command create user username identified by password in container level, that user will be created under container level. Same command if you use on pluggable database level, it will be created under pluggable database level. C hash you need to mention. Prefix we need to mention, that is a common user. Now understand the next thing. So by any chance, if you want to go back to the container level, you can fire a command like alter session set container equals to cdb $root. If you are going to this container level, okay, and if you fire shutdown immediate command, okay, now what it will do, this is also one disaster, right? It will stop your container as well as it will stop your pluggable database also, all pluggable database, correct? But if you start your container database, it will not start your pluggable database. Pluggable database you need to start manually, okay? So I just shut down my database, and if you try to do show PDBs now, you will not be able to see your pluggable database, okay? You will not be able to see. So what activity you guys are doing in your container level, container and pluggable database level in your real-time production environment? PDBs to from where to where? How? By using what? Directly SQL developer, is it possible? Okay. So when you say that migration from one container to another container means basically you have one, how is that? Data pump, okay. But when you take unplug and plug, then it will create that data file backup and that XML file, right? So that data file you need to move to that new server, correct? But that data file, if it is like, that backup will be very huge. Okay. So I just started my container database. Okay. Now there is a command is there that if you use that command, it will straight away start all your pluggable database. But if you want to start specific pluggable database, you can start. Also, there is a way to automatically start your pluggable database also as soon as you start your container database. That, yes, as soon as you start your container database, if you think that, okay, this pluggable database I want to start automatically, so that way also it is there. just for starting your pluggable database? Hmm. Let's see. We'll see that. So see here, if I fire show PDBs, now you can see my show PDBs. My pluggable database are not running, right? But by any chance, if you think that you want this pluggable database to be started automatically, there is one option is there called save state. Save state. Okay, you can use that. Just remember this terminology. Is save state. If you want to know more about that, go to our website, and I have written one blog that will help you. Go to the search, and search it with save state. So what it is doing, like as soon as you start your pluggable database, let's say you want ultra pluggable database name save state. So you need to start this pluggable database. As soon as you start your pluggable database, and if you save the status of that pluggable database as save state, then what will happen next time when you shut down and start the pluggable database, that database will be going into the read write mode. So whatever status you have saved, that will be the status even after the restart also. You can see rest of the pluggable database is mounted, but this pluggable database is in the read write. Why? Because we have saved the state. What is the saved state? It was startup, right? That's the way you can do. Is it clear, everyone? No, what this C is for cloud. Cloud means this is the same database you can use in your cloud also, as well as on your premises also, on premises database also. Means this database, like starting from Oracle 12c, it means 12c, 19c, 21c, these databases are supported by the cloud also. Now let's say you go to the AWS or maybe Oracle Cloud, or even AWS have the RDS instances are there. RDS, we call it as RDS. That RDS provide you the multiple relational database like your Oracle, MySQL, PostgreSQL, all that database they are supporting. Okay. So that time it will ask you like which database you want to install. So you will not have an option of 11G. You will have an option of 12C, 19C, 21C. These options. Anyone is working on the cloud now here in this class? OCI. What do you people do in OCI? Hmm. So any activities which are getting changed from non-cloud database to there. So how are you starting the database? Same way. Like let's say you want to start the database, stop the database, you want to take the backup. Convert is fine. That is a GUI tool. But when your database get hosted to which cloud you are using? Oracle, OCI only, na? So, but you are not finding any difference when you are So backup part you are taking care only, right? Okay. How many data cards you have? Like how many nodes? 800 databases. And how many standby? One standby only, right? Three standby. Okay, nice. Hmm. Okay. And is it with the rack also? Rack with data card? Okay, nice. And what is the size of your databases? 48. And how much memory you are allocating there generally? Memory like SGA. Huh. So it will be automatically calculate or how? Hmm. But initially you might be giving less memory, right? And then later on you might be increasing. 60/40 means how? Of what? Server, you are saying? Okay. Okay. The total amount of memory which you allocate to the server, among that 60% you are giving it to the SG. Fine. Okay. That there is no standard. There is no standard in that. Usually, like that is all depending upon the necessity of the business, uh, the amount of load that you have on your Oracle database, what application you are connecting to this database, how much load, all that factors will be calculated, and then we can decide like, okay, this is what we can. Initially the people will always go with low memory as soon as the demand, because at the end it's a parameter, right? You can increase that, and you have a platform team. No. No, it is a, see, it's a parameter na, at the end. Where is that parameter value stored? In parameter file, correct? So if you want to increase the SGA, no, it is a shared. Your SP file is shared in between instance 1 and instance 2, correct? Your P file is a local. Okay. So that's how it works. So in this multi-tenant architecture, like if you want to move from one server to another server, you want to do anything, you need to be ready. Okay, one more concept I want to tell you, in multi-tenant only. So there is a concept called common user and local user. Okay, what is common user? Let's say this is my CDB, and under that CDB I have this multiple pluggable databases are there, PDB1 and PDB2. Okay, if you want to create a user, okay, so if you want to create a user, the user can be created on container database also and on pluggable database also. But usually in real-time production environment, we don't create a user on container level, because the problem is, let's say you create a user ABC here on container level, that will be created under all pluggable database. That is called common user. So common user is like a administrative user, and it has a prefix called CHH. You need to provide a prefix called CHH and then username. So if you say that CHH ABC, CHH ABC, CHH ABC, there are certain common users are already get created under container level, like sys is there. You can see sys here also, sys here also. So you have a user called sys, system. All these users are common user, but these are the exceptional user in which you will not find your any CHH and something like that. Okay, that is the reason you can see like you are able to use sys user, system user under container as well as in pluggable database level, because these are the common users. Now, where you create a user, you will create a user under pluggable database only. That is called local user. Okay. If you create a user locally, let's say you create a user here, U1, that will be created under local pluggable database only. Only local. Locally here. Not in container as well as not in pluggable database level. Other pluggable database. If I create in PDB2, that user I created under PDB2, that will created under PDB2 only, not in container level, not in another pluggable database level. That is called local user. Okay, that is called local user. So these are the two type of users you will find when you are creating under local user and common user when you are talking about the multi-tenant architecture. But always create a user under local only. So are you guys getting request of creating a local user? You Satyam. PDB user. There are two type of profile also there. One we called it as a common profile and local profile. Same way. Local profile means the profile which you created under pluggable database only. So it will be accessed by only pluggable database user. That pluggable database user. Okay. If you create a profile here in the under PDB1, assume that. So that will be used by only user of that pluggable database. But if you create a common profile, let's say you create, but again the common profile you will start with the CHH and profile name. That will also get started with CHH only. PDB only, correct. PDB only. We don't create. See, normally we don't create anything common. Like common is basically that's a dangerous, because that will be created under container as well as in pluggable database level. But I have one more confusion in that. Okay, there is a keyword like container equals to all. Okay, right? All is keyword is there. What I am thinking? Okay, I don't know exactly. I am thinking that when you say container equals to all means that will be created under this container as well as this container. You got my point? When you say container equals to container name, okay, did you cross check anytime? What does it mean? Okay, then if I want to create it under container only, then container equals to current. Let's do that. Okay, see here. Let's see, no problem. Okay, where I'm right now, container level, right? So I'll use the command like create username CHH CDB user. Okay, identified by password is Oracle. I created that. Okay, I did not mention anything. Where I can see this user, select username from db underscore users, where username equals to CHH CDB user. Can I see here Yes. Can I go to the pluggable, alter pluggable database? No, sorry, what is that command I'm using? Alter session set container enter equals to PDB prime. I'll use the above command. Can I see that? Okay, I got the error message saying that pluggable database not open. I want to start that, so simply use the command startup. Okay. Alter pluggable database name open. Okay. From the container level itself, you can do that. But when you are inside the pluggable database now, you can use simply startup. Now I started that. Okay. Let me see that. I got the user. Okay. Now let's do one thing. Let me go to the container level. Okay. So I'll say cdb $root. Let me create one more user. Create user c hash test user identified by Oracle. What is that? Container equals to all, right? CONTIN. I want to create under only container database. Then what is that? Current, right? Just see that, no problem. Let me go to the pluggable database level. And let me fire this command. Okay. Where it is created? That is a local user. This is under PDB only. But if I use container equals to all, then what will happen? Common detail only allowed in the root. So if my understanding is correct, okay, I am thinking that container equals to all means all container. All container means the containers which are running from same Oracle home. You got my point? That is what I am thinking. Okay, that's how. Correct. See, let's say I have Oracle 19c container. Okay. Now two containers can share the same Oracle home, right? Right. Now if I create a user here, that will be created here also. If I use container equals to all. Okay. I am just guessing. Okay. You guys do some research and let me know also. Okay. It's my question also, but let me know. So that's how the common user, local user, and like all you people already aware about the permissions role and all these things, right? So that's pretty much simple how it happened in the container level and pluggable database level. I have one question. If I use show PDBs, I can see my PDBs up and running. Okay, let me go to the from here, and if I use show PDBs, can I see read write? Show PDBs, but here it is mounted. I just thought so. No. Start pluggable database in the rack. See, I'll tell you one example. There is a small command is there. Okay, that we need to add. Where is that? ultra pluggable database, close instance, open instance. Okay, close instance, open instance. Now let me see one more block. You need to use a PDB. I can connect back to the no problem. You need to use this command only, close instance and open instance, if you want to start and stop your pluggable databases. Ultra pluggable database all open. Let me see that. I'll tell you why it happened. I'll tell you why. See, if I want to start my database, what is the command you are using? SRVCTL. We are not using startup. Startup is only useful to start your that instance, right? See, when I fire a command like SQL plus / sysdb, it means I got connected to instance, not database. Correct now. We are not connecting to the database. Database terminology will come in the picture when you are talking about the SRVCTL start database. Correct. Now when I use the command like I created user and all, so basically everything is doing under the instance only. Okay, let me do one thing. I'll start this pluggable database. Okay, alter pluggable database PDB prime open. This is the way we are starting our pluggable database. Correct. Now the user which we created, can I see that user here? Let's see. But where user will be created? Now I'll go, and where is that user? I was able to see, this is the one, right? I can see the user. Try to understand where the user get created. Database level, not on instance level. Correct. Understanding na, right? Database user will be created on database level na, not on instance level. Now PDB is like an instance actually. When you say Oracle SID, it is an instance. Correct. When I connect to the SQL plus / sysdb, there is a chance that, okay, let me do one thing. I'll stop the database now. I'll do like srvctl stop database -d and database name. I stop the database. Now what I will do, I'll start the database, and then I will start the instance, then I will start the PDB with that instance level command. Okay, let me show you one by one. I stop the database. Let me start the database now. You can do that na? We have used that option. -o was there. We did that. We used that. First day we have seen that. We can call DBC and create one more CDB. No. We already have Oracle 19c, right? Installed software. But that CDB will be created of which version? 19c only, correct. So I started the database, right? Now I want to start the pluggable database. So I'll say ultra pluggable database name, instances. Let's start it. Both the 1 and 2 is there, na? 1 and 2. To start PDB Spark, you must start the respective services. How is it done? I think we need to create services. Okay, now if I go here SQL plus /SDB, can I see that show PDBs? PDB prime is mounted. Now what I will do, alter pluggable database. What is that command? Alter pluggable database, open instance, PDB prime, open instance instances. What is that? Prime 1 and comma prime 2. Open instances equals to I think we need to give comma separated also. Somewhere I have seen 2 instances. Where is that? Is comma separated. Prime 1 comma prime 2. And if I do show PDBs now on node 1 and node 2, we will try that. So if I use show PDBs, here it is read write. Here if I use let me do exit, nothing is
Incoming call from Technology Office.
Show PDBs. It's working, right? it's working, right? So do we have instances equals to all? Just instances equals to all. That's also working. That's also working. If you know the it's there, you can use that. Okay, so that's how you can start. But when I was reading the blog, I got to know that there is a concept called services. We'll see that in our class also. If you start the service, it will start your instance also. Okay, so I'll talk about that, what is services on in future classes. So that's also one thing we'll see in the next class. Okay, so let's connect tomorrow and we'll see the remaining part of it. Okay, yeah, I'll check that. Okay, tomorrow maybe before class we'll see. Okay, and we'll do that. Thanks guys, bye bye.